What's up, everybody? Welcome to the 16th lecture of Contemporary Math. Today we're going to be talking about simple and compound interest. So chapter 8.3 and 8.4 in the book. I don't know why I just pointed to it. You can't see the book over there. Anyhow, let's talk a little bit about what interest is. Interest is whatever whatever extra a borrower pays to borrow money. So if you're investing or lending money, you get paid interest because you did a service for someone else. You said, here's the money you want, but when you give me that money back, I want some amount of interest on top of that. Or it could be the other case where you're the borrower, go to a bank for a loan, right? And the bank in return expects you to pay a certain amount back, a certain amount extra because it provided a service. This is by definition what interest is. So interest, in the case of simple interest, is calculated by multiplying the principal amount times the rate of interest times the amount of time that is being borrowed for. All right, so what's the principal amount? Well, the principal amount is whatever you're pulling out or you're putting in. The rate of interest, usually, more often than not, it's in terms of years. So we might hear an annual rate, the interest per year. And the time t is going to be in the same amount of time as the interest rate is. So if the interest rate was in days or weeks, time would be measured in days or weeks. But usually it's in years, and we're going to default to assuming that it's years for all of this stuff. Having said that, let's look at an example. So we've got a student who pulls out a 2-year simple interest loan. The loan's for $1,800. It's at an 8% per year interest rate. So we want to know how much that student's going to have to pay on their loan, how much interest they're going to have to pay. Well, the principal amount in this case is going to be the amount that the loan gets pulled out for, $1,800. The rate is going to be 8% per year, okay? And the time is going to be for 2 years. Cool. So the amount of interest that the student's going to have to pay is going to be $1,800 times 8% times 2 years. Well, it's not quite that simple though, because we have to convert that 8% back into a decimal. Okay, no problem. We talked about that in the last lecture. So it's 1,800 times 0.08 times 2. When we multiply all of this through, we find that the interest rate, or the amount of interest that the student incurs, is $288. So this is the interest they incur, right? So that means on top of what they have to pay back for the principal amount, they also have to pay back the $288. Cool. This is the gist of it. It's really not too terribly crazy. But having said that, let's look at this really quick. So we know the interest is $288. So the amount that the student is going to have to pay back is going to be the principal amount plus the interest, right? So $2,088. But we don't want to have to calculate this each and every time. This, having to go through, find the interest rate, and then add it to that, it gets tedious after a little while, right? If we were a bank doing a bunch of these loans, we definitely don't want to have to go through this entire process. So surely there's a better way of calculating the amount owed at the end of whatever the loan period is. And there is. If we think about what we've just done here, we said that the amount owed is equal to the principal amount plus the interest, but the interest is equal to the principal amount times the rate times time. So that's P plus PRT. Notice here, we've got these two P's though. Means we can factor them out. When we factor them out, we find that the amount owed is 1 plus RT times P. So what we've just found is a little bit simpler way of calculating the amount owed at the end of the loan period. And that more simple way is just P times the quantity, so everything inside the parentheses, 1 plus RT. Cool, let's move on. Before we move on to compound interest, I want to take a second to consider this example behind me. Let's say you're planning a trip in 2 years to Europe. You know that trip's going to cost you $2,000, but you're like, hey, I got some time, why don't I save money and invest this money into what's called a certificate of deposit? So you call up your bank and you're like, all right, cool, hey, I want to buy a certificate of deposit, what's the simple interest rate on it? Your bank tells you it's 4%. Like, cool, awesome. So you sit down with pen and paper and you're like, how much do I need to put in order to have the amount of $2,000 at the end of my 2-year period? How are we going to solve that? How are you going to solve that? Well, in this problem, we know things a little bit backwards from the previous problem. Instead of knowing the principal, we know the amount that we want, right? You want at the end of this certificate of deposit, at that 2-year mark, you want $2,000 in your account. That's going to be the amount. And you know that the simple interest rate is 4%. And the time is going to be 2 years. Okay, now we're going to have to rearrange our equation to figure out what the principal is. To do that, all we have to do is divide both sides by 1 plus RT. So we find that the amount divided by 1 plus RT is equal to our principal amount. Cool. So now it's just a matter of plug and play. We know the amount, $2,000. divided by 1 plus 2 times 4% as a decimal is going to be 0.04. But we can go ahead and start reducing some of this a little bit. It's going to be 2,000 divided by 1.08, which is going to give us our principal amount. Once we do the division, we're going to find that the principal amount is about 1,851,852. No, I did not do that in my head. I have a cheat sheet on the board across from me here. Okay, so we found our principal amount is $1,851.85 and some change, right? Well, in this case, we're going to have to round it up. Because if we round it down, we won't have the $2,000. We're going to have to round it up. We're going to find that what we need to put in is going to be 1,851.86. And the reason, again, why we're rounding up is because if we put in 1,851.85, then we're going to be a few cents short at the end of those 2 years. Whereas if we put in an extra cent, an extra penny, we're going to be a few cents above where we want to be. Okay, cool. So, looking at all of this, question might come up, what is a CD and why didn't the bank give me 4% to buy a CD? A CD is really just an amount of money that you give the bank to let the bank do whatever it wants to do with that money. And you give it to the bank within a certain period of time. So it can basically use your money for however long your particular CD lasts. And at the end of that time, it gives you that money back plus whatever the interest is. So in this particular case, in this problem, what we're saying is, if you want to buy a CD that'll last for 2 years at a rate of 4%, and you want at least $2,000 at the end of those 2 years, well, you're going to have to buy your CD at a principal amount of $1,851.86. That's what this problem is saying. Having said that, let's move on to compound interest. Before I get into explaining too much of what I've got up here, I want to first explain what the difference between compound interest and simple interest is. Simple interest incurs interest once, only one time, based off of that principal amount. Compounding interest says, all right, let me take the interest this first time, add it to the amount, the principal amount. Now let me add interest to that. Now let me add interest to that, and it keeps compounding the interest. So the difference is simple interest happens only once. Compounding interest happens over and over and over. The interest, the amount, gets larger with time. So compound, larger with time, simple, one-time interest. Having said that, there are two different types of compounding interest. There's the kind that happens over a period within a year. So you might have interest that incurs once every 6 months, once every 4 months, once every 3 months, 2 months, however. And in that case, it would be compounding over in periods per year. On the other hand, we could have compounding continuously. And it literally means that it's compounding exactly what it sounds like, continuously. It's not once every 2 months you get hit with interest, like this would be. Instead, compounding continuously is the second that money happens, the second that transaction occurs, it begins gaining interest over and over and over. There is no interest for this chunk of time, interest for this chunk of time, interest for this. That case would be compounding over in periods. No, instead of continuous, it is, again, quite literally continuous. Having said that, you might be looking at the formula for compounding continuously, saying, what is that E? Well, like, what is that value? Happy you asked. So what these formulas, let me step back a little bit. What these formulas are telling you is the amount owed at the end of the contract, or at the end of a time period, given some principal amount, the rate, the time. In the case of compounding over n periods, n is the number of periods. In the case of continuous, though, we have this E. Like I said, I'm happy you asked what that E was. That E is called Euler's number. No, it's not called Euler's. Say it in front of me, I will fail you. No, I'm just kidding. I won't fail you, but it is Euler. So what this E actually amounts to is approximately 2.1 or 2.72. I'll let you round it off to that. It's actually a infinitely non-ending decimal. So that decimal goes on forever. An irrational number for whatever that's worth. All right, so a lot of information. Let's look at these two different types of compounding interest and a problem. In this next example, what we're looking at is an account, a savings account that we just put $7,500 into. And that savings account is incurring interest at a rate of 6%, compounding monthly. And we want to know how much money we'll have after 5 years. And then we want to compare that to if it was compounding interest continuously. And as a reference here, I wrote out the formula for compounding over in periods, right here, and compounding continuous, right here, just to kind of help us organize our thoughts. All right, so looking at this problem, tackling the first part, if it's compounding monthly, then that means our period should be 12, right? Because there's 12 months in a year, so n must be equal to 12. We know our principal amount is going to be $7,500, and we know our rate is going to be 6%. And finally, we know time is going to be 5 years. Putting all of that together, using this first formula to answer the first part, we get this up here. Again, we know our principal amount, $7,500. We know the rate is 6%. We're going to have to put that into a decimal, though. We know the period is 12 months in a year again. And we know t, time, is going to be equal to 5. It's over 5 years. Throwing all of this together now, inside of the formula as provided here, we're going to find that after 5 years, we have $10,116, well, we have about $10,116.38. Comparing that now to if it was compounded continuously, we'll have $10,120, $10,123, excuse me, and 94 cents. In other words, if it compounds interest continuously, the amount is a little bit larger than if it's over a set of periods, over a period of time. Cool. Pretty straightforward, right? Just taking the information that we're given and throwing it into the formulas. All right, let's move on. The last thing I want to talk about in this lecture is effective annual yield. And what it is a simple interest rate that would, at the end of 1 year, earn the same amount of money given the same principal amount. The way it's calculated is using this formula right here. 1 plus r divided by n, all of that as a whole, the quantity, raised to the n minus 1. What y is here is your simple interest rate. What r is your compounding interest rate. And what n is the periods, right? So you might be asking yourself, how the hell did they come up with that? It's a good question. The way they came up with that is they started by looking at simple interest rate, or simple interest, and compounding interest. Said, all right, we know the formula to calculate the amount of money after some period of time for some simple interest rate and for some compounding interest rate. All right, cool, let's start there. We're going to set these two formulas equal. P times 1 plus, in the case of simple interest rate, to keep us from confusing the two rates, because they are going to be different, likely, yeah, they don't have to be different, but they most likely will be. They said, to keep us from confusing those, let's substitute this rate with just a y. Let's just write it as y here. All right, so we're going to set these two equal. P times the quantity 1 plus yt is equal to P times the quantity 1 plus our compounding rate divided by the number of periods raised to the number of periods times t. All right, we want to simplify this. The very first thing we can do is divide both sides by p. When we do that, we find that 1 times the yearly simple interest rate times t is equal to 1 plus the compounding interest rate divided by the period raised to the period times time. Okay. Now, we want to reduce this a little bit more if we can. Luckily, we know that t here is going to be 1. We know that because it's after 1 year that we're measuring this for. All right, so we're going to put in 1 there. Put in 1 for t. Now you may notice, hey, I can drop these parentheses right here. Yeah, drop them. Then all that's left is to subtract this 1. Nope, my mistake. I made a mistake there. I meant to set them equal to each other. Okay, so we drop the parentheses. Now, we can subtract this 1 from both sides. When we do that, we end up with y is equal to 1 plus our compounding interest rate divided by the periods, that entire quantity raised to the n power minus 1 is equal to the yearly simple rate. And that's how they found this. Now, you might be asking, why is this important? This is important because this is, in some sense, a true measure of the interest rate. This is the number that helps us really honestly capture, measure the interest rate. Yeah. Having said that, if you have any questions, by all means, shoot me an email. Happy to help. Have a good one.